Hi, in this video I will be solving the numerical questions that we had in the problem set, but we didn't have time to do them last Thursday, so we'll start with question number 36. So if you open the problem set now, you will see that question number 36 is this question here. It's about portfolio returns and individual standard deviations and portfolio standard deviations. Okay, let's look at this, what's given to us. So returns on the stock of First Boston and Midas metals for the years are shown below. So we have First Boston for 4 years and Midas metals and portfolio return that we need to calculate here. Right, so first question is compute the average annual return for each stock and a portfolio consisting of 50% first stock and 50% Midas stock. Right, so let's start with computing the average returns for each of these. So let's start with Midas. Now, as you all know, average returns RM, which stands for R Midas, is basically minus 18% plus 32% plus 18% plus 1%. So this whole column here, and everything else divided by the number of observations, which we have 4 here, and it should give you something like 8.25 basically. This is the average return over this 4-year period. Now average return for sorry, this is First Boston, wasn't it? Yeah, the Midas is now this column, basically the same thing. Very easy question. Plus 3 plus 10 all over 4, and that is something like 850. Right, so these are average returns. Now we need to calculate the standard deviation for the, wait a second, so we need to also calculate the portfolio returns. So these are average returns for each of these, but for portfolio returns, so for each year, basically we need to calculate here. So in that case, so this would be for 2010, let's say 2010, for portfolio in 2010, portfolio return in 2010 would be, let's call this RP would then be minus 18% times the fraction of cash that's invested in First Boston, so that's 50%, so this is 0.5, plus the return in the first year from Midas is 26 times the fraction of cash, which is then 0.5, so 50-50 basically. This gives us something like half of this, 4%. For 2011, RP then is equal to, again, 32 times 0.5 plus, well, this is minus 5 times 0.5. This gives us about 13.50%. Now 2012, RP is equal to 18 plus 3 times 0.5 equals about 10.5. 2013, now the same, so 1% times 0.5 plus 10% times 0.5 gives us 5.5 portfolio returns. So these are portfolio returns. Now that we have portfolio return for each year, we can calculate the average portfolio return for whole period, from 2010 to 2013. That will be the average of all this. So it will be average portfolio return with the bar. Now we have 4% plus 13.5 plus 10.5 plus 5.5, all of it over 4. So that gives us something like 8.38%. So that's average portfolio return now. Next, I think I will now need to clean this board because I won't have enough space here to write any further. So next thing is to do the so we've done A now, yeah, this is A. So we'll do now this, compute the standard deviation for each stock and the portfolio. So this is what we're going to do. For this I will need to move this a bit up. Can I? Yes, I can. Yeah, nice. However, I need to now delete this. So if you're copying, stop the video here and then copy. No, can I move? Yes, I can. However, I will be losing the numbers. I mean, I won't be able to see all these values, so I have to just delete this anyway. So I could scroll down, but I will be losing the sight of all these tables and values in it. So now B. Oops. B. It says compute the standard deviation for each stock and the portfolio. Now, if you remember, we know that for First Boston, the average return was for the whole period, was 8.25. Now, then standard deviation for First Boston, STF, would then be square root of sum of the squared deviations of returns divided by n minus 1. So we'll have to now expand this formula by plugging each of these returns into this formula. So that will then be STF equals square root big one. First was 18%, so that's this value here, 18%, minus the mean, that's RF bar. So let's do this, minus 8.25 squared plus, so let's save some space, plus the return in 2011 is 32 minus the mean return 8.25 squared plus 18% from 2012 8.25 squared plus 1%, which is the last one here, minus 8.25 squared, and all of it is on the square root and divided by n minus 1, which is basically in this case 4 minus 1. Now, as you can see, it's a very simple question. It's not difficult. In the class, for some reason, you found it difficult, but it is not. It's very, very easy. So now standard deviation for First Boston is then, if you calculate this and take square root of that value, then you get 21.61%. Now we repeat this exercise to calculate the R midas. So ST midas, standard deviation of the other one, midas metals. Yeah. So for that I will still be looking at the numbers, so going down won't help me, so I may have to just erase some parts of this. Anyway, so now we know that R, so let's put this, we know that is RM was equal to, that we calculated earlier, was equal to how much was RM? Was 8.5%, and standard deviation for STM basically will be the same, except that the numbers will change now. So standard deviation M is equal to square root big one of deviations of these values from the mean. So it's first one is 26 minus 8.5 squared plus second one is minus 5 plus 8.5 squared plus 3 minus 8.5 plus, so this square here, 10 minus 8.5 squared, all of it on the square root, and we as usual divide them by 4 minus 1. 4 is because there are 4 years here, so the answer for this will then be something like 13.18%. So this is the standard deviation of Midas. Next step is to calculate the standard deviation for the portfolio. So for the portfolio it's slightly different. We have to use the portfolio theory for that, and I guess you remember that from school, from the class, that it's not that difficult as well. You just need to memorize here in this case standard deviation of portfolio, formula for standard deviation of portfolio. If you remember, it was sigma equals, basically it's usually sigma square variance, we say it's W1 squared, so in this case WF, that's first Boston, times the variance of first Boston, plus WM, the weight for fraction of funds spent, invested in Midas, times the variance of, this is squared by the way, variance of the company, and then comes the 2 W1 or WF times WM times covariance between the two. So this would be return F, return M. Yeah, this should be interesting to do. Now what we need here is that we have to calculate the covariance between RF and RM in this case. Now this is gonna take a little longer to do. What we can do is if we could calculate the, in any case we will need the covariance formula for this one, because the result won't be weighted average, so we will still need to get the covariance. How do we do that? How do we get the covariance? Well, we can use the covariance formula, which says, if I remember, RF and RM equals sum of the products of square deviations, or not square but just the deviations themselves. So that's M as well. These are simple, each of the returns from the table above, and this is again n minus 1. Now this is going to be a bit time consuming now from now on. Right, let's see. So I will still need to see what's in the table, so that will be difficult now again. It is time consuming. It will be, so I'm copying the table here next, which is not visible here to you, but it shouldn't take long now. So this would then be, it's a long one now, minus 18 minus the average 8.25 times 26 minus 8.5. So these are averages that we calculated, and these are each of the returns for each year, plus next one, deviation from mean value of what's this, first Boston, times the deviation from mid value of this next one. What's this next one here? Midas, sorry, I'm trying to read it, but it's not here, so I just had it forgot it so quickly. Plus, okay, this is going to be a hard one, so I'll have to put some brackets here at some point. 8 minus 8.25 times this is now 3, isn't it? Yeah, 3 minus 8.5 plus, what's this, 1 minus 8.25 times 8 point, no, it's 10 apparently, so it's 10. The last one, 10 minus 8.5. So altogether, once you sum up, divide by n minus 1, so that's 4. Now this is gonna take time, and I don't have the calculator for some reason. I should use Excel for this time now. Instead, I'll just use Excel's function. Excel's function that helps me to do the covariance. If I just use new, so I'll just do covariance here. So if you have calculator, you don't really need this, but because I don't have one, and in the exam you will be dealing with such questions. So this is the covariance. It appears a negative correlation, so minus 0.02. So let's have that here, minus 0.02. So this whole thing, basically, this whole thing is equal to minus 0.02. Now coming back to this, so this whole thing is minus 0.02, so we will now calculate variance. So this will then be square of the fraction of cash invested in W, so that's 0.5 squared times sigma f squared for first Boston. This was, remember, this was the sigma was the standard deviation, so if you square it, so standard deviation of square of 21.61 basically, plus, but because standard deviation was 21.61, so now Wm is 0.5 squared times the sigma f. Sigma f was 13.18, again squared, plus 2 times 0.5 times 0.5. yeah, so these are 2 w's. It's not allowing to, so these are 2 w's, 2 w of Wm times the covariance times minus 0.02. If you remember, this was what we have just calculated, and if you calculate this, I think you should get something like by the way, this will look standard deviation, so take a square root instead, because with the square it will be variance, but if you take the square root, this 2 disappears here, then you will have the result 4.4%, roughly this amount. So check this please, this should be correct. If not, we will talk about in the class next time. Okay, so that's done for B. This is the portfolio standard deviation. So this is portfolio standard deviation. Yeah, it's not difficult. All of it is just repetitive. It's just looks kind of complicated, but very easy question. Next thing is, let's have a look at C. Are the stocks positively or negatively correlated? Now, because covariance is negative, correlation is definitely negative, so the stocks are negatively correlated. And what is the effect on risk? Because they are negatively correlated, the risk will be smaller than the portfolio risk will be smaller than the risk of individual stocks. So riskiness of this first stock is 21.61%. So this is the volatility. Second stock, Midas, is 13.18, again volatility. So the first stock is more volatile than the second one, but when you combine them together, actually the volatility comes down to this 4.4%. So which is actually a very efficient portfolio. Has a quite low risk in it. And also remember that average return was still 8.38 as well, which is even, I mean, for a given small risk, you have achieved almost uh, as high return as the RM return. Yeah, RM return was, I think, highest. Yeah, 8.50, while portfolio return was 8.35, and RF return, average return, was 8.25. So it's in between them, and between the two values here, basically. Okay, that is C done. Now question number 37. This was also in your problem set that we didn't answer, so let's read it. You have gathered the following information concerning a particular investment and conditions in the market. Okay, so we have risk-free rate, market return, beta of investment. Okay, according to KPM, the required return for this investment is, so very simple question. So required return using the expected return, in other words, using KPM formula, is RF. So R required return is equal to RF plus beta. So this part is risk premium, risk adjusted risk premium, let's say, RM minus RF. Yeah, you just plug in the numbers. Now you have RF, which is risk-free rate, 2.5%, plus then we have beta 1.35, and RM is 11. So from here minus risk-free rate, and if you just work this out in your calculator, you should get something like this. Yeah, with the 1.35 beta value, this stock is quite risky. Well, it moves, is quite sensitive to changes in the market. Yeah, movements. Sorry, it's risky, it's sensitive to market movements. Anyway, so this is the result. Next, 38. Apparently, what we have here is that Jonathan has the following portfolio of assets: 25% in A, 40% of cash in B, and 35% of his cash is in C. Different stocks, assets in a, and betas are given for each one. So the A is more riskier, so he invested little. B is actually less, I mean, the sensitivity to market is less, and C even less as well. So what is the beta of Jonathan's portfolio? So beta of portfolio beta P, is basically sum of all the well, weighted average, I should say, weighted average of all betas. Weights are basically fractions. If it's J I, then beta J. So 1, so J running from 1 to N, depending on how many assets you have. So in this case, N could be 3. So let's do this because there are 3 assets. So we'll calculate this now. So this would be W1 or WA times beta A plus WB times beta B plus WC times beta C. So stock WA is here 25, so this 0.25 plus beta A is 1.70. Sorry, this is not plus, this is actually times 1.7 plus WB is 0.40, so 40% times 85, 0.85. Then comes the weight of stock C times the beta of stock C. Could be any asset, but let's assume it's stock. So if you just multiply them, you will get 1.04. As you can see, beta, overall beta of portfolio is lower, because lower than A however it's higher than the 2 because we are basically the low betas pulling this down. Basically average portfolio market response to market movements of average portfolio is almost the same as market's own risk level. Okay, next one. This is, I think, 38, not 8. It's missing 3 here. So let's read it. Marco owns the following portfolio of stocks. What is the expected return on his portfolio? Well, it's an easy one again. Expected return on portfolio will then be, as usual, sum of the weighted average returns. Yeah, weights are the fractions of cash that you invested. So this is gonna be I times the return from each portfolio. So this would be I equal to 1, 2, 3 in this case. Yeah, so this would be then WL times return L plus WM times return M plus WN times return N. So these are labels of stocks, so I just kept them there. So let's put them in now. Now how much is this? What fraction of total cash is 3,400? So in this case we just need to divide 3,400 over, so this is 3,400 over total amount. So what's total amount? So that's 0, 0, 406 is 0, 3, 13, 15, 16 apparently. So that is 16 here. So sum of all this, and times RL. RL is this value here, so this is minus 6% plus WM is now 10,000 over 16,000 times the RM. RM is 7.5 plus WN now is 2,600 over 16,000 times 12.6 and equals, if you calculate this you should get 5.5%. So that's the portfolio return on stock. So these are stocks. Okay, next question is question 39. What is the expected return on a stock with a beta of 1.09, market risk premium of 8%, and the risk-free of rate of 4? So this is an easy question as before. Required rate of return is then RF plus the beta market return. So this is R. Make it clear to you. This is RM minus RF. So this is then, we have RF which says 4% plus beta is 109 times, this is times then risk premium, so that's this 8%, gives us the answer of 12.72%. right? So next question now. 40. According to MSN Money, the stock of Orange Corporation has a beta of 5. Let's say beta of Orange is 1.5, sorry, but according to Yahoo Finance it is, okay, this is according to Yahoo. So there are two different betas. One is beta 1 Orange, beta 2 Orange. These are not square. Beta 2 Orange is 1.75. So this is according to MSN, this is according to Yahoo. This is, simply possible because Yahoo may use different periods while Orange may use different sample periods, so that variation is possible. Okay, the expected rate of return on the market is 12%. So at the same time we have market return which is 12%, and the risk-free rate is equal to 2%. Now what is the difference between the required rates of return calculated using each of these betas? Okay, so let's calculate the required rate of return first using MSN. So M MSN beta. In that case it will be 2 plus MSN beta was 1.5, then risk-free market risk premium is 12 minus 2. Now our Yahoo required return according to Yahoo's in beta is then will be 12 minus 2. I guess you know how to do this now. So if you calculate, so basically what we do is you get some value here. So this is 10, 15, you have, oops, this is 2, isn't it? Yeah. So 15 here, this is 17%, and in this case the difference is 10, 17.5, 2 is 19.5, 19.5%. So the difference between them is gonna be 2.5%. Yeah, you subtract the smaller one from the bigger one, so this is the answer, right? So the required rate of return, difference in the required rate of return between MSN beta, according to MSN beta and Orange, so and then the Yahoo beta is 2.5%. You see a huge difference here. Just small mistake or small difference in beta is making a huge difference. In fact, the difference in the beta is actually reflected on the returns. So because the difference between 1.75 and 1.5 is 0.25, in some way it's basically the difference is magnified. Yes, because the market, this market, what you call this market premium is 10% in that case, in each case, isn't it? The only thing changing is here, so we didn't even have to add this up anyway. So 2.5%, that's it. So I'll see if you have any questions. You can ask me in the class, but for now it's all done. So please try to do kind of more of these exercises in the book or online, but yeah, do as many as you can as to understand the whole topic. Yeah, okay, see you in the class then.